Everyone, welcome back to my channel, and in this video we'll be working with Amazon customer reviews dataset, and with that dataset we are going to predict the rating of a particular product, and we'll be going from end starting to end. Like, we'll be doing all the operations such as doing visualizations and understanding different features of the dataset, checking whether we have null values or the outliers in the data, finding correlations among different columns using correlation plot, and how we can do feature engineering using the columns that we already have. And then we'll be trying to predict the rating, and we'll also make use of the reviews columns, and we'll try to see whether we can perform any kind of NLP operation to it, so that we can convert it into a format which we can pass it to our machine learning model. And once we are done with all that, we will split our data into train and test, and we'll use various machine learning models such as decision tree, random forest, logistic regression. And we'll also be using various metrics such as classification, report, and confusion metrics to check out our model. And after all these things, we'll be trying to find out the sentiment also using the libraries such as WordNet. So without further ado, let's uncover the secrets hidden within this Amazon customer dataset. And now let's go through the code, guys. So let's start with the process, guys. So the first step is to install the necessary libraries. So we started by installing TensorFlow, as we'll be using TensorFlow to get our data, Amazon dataset. So we use that TensorFlow, and we imported the TensorFlow datasets, the train test split from sklearn model selection, the pandas, numpy, the usual stuff. Okay. So this is how the TensorFlow, the TFDS TensorFlow dataset, we loaded the Amazon US reviews, specifically the toys dataset. Okay. So once we have that, you can see what we get back in dataset. We get an object. Okay. And all the data is present in that data key. We get an object where we have customer ID, helpful votes, and all that things. Okay. And using the information, we can see the description of each and every column, what that actually corresponds to. So now let's try to extract all that data. So how we did that? We looped through all that. We just took 20,000 items from all that data. The data was very huge, guys. So I'm just getting 20,000 data, and we are extracting all these features out of it. The customer ID, helpful votes, marketplace, and so on. Okay. And our goal will be to try to predict this rating of that particular product. Okay. So we are getting all that information, and we are appending it into this list, that data list that we have created above. Okay. So once we have that, what our next goal is, we converted that into a data frame so that we can perform all the pandas operations, can apply machine learning algorithms easily. Okay. So we are converting that into a data frame, and we have saved that into a CSV so that we don't have to do, if we want to run that again, we don't have to perform fetch all the data from TensorFlow datasets, and we can easily read this CSV and perform all the operations. Okay, so let's try to see what we actually get. So once after this, what I am doing is I'm printing the shape and the head of the data to see what we have actually got. So as you can see, we have customer ID, helpful votes, the marketplace. The marketplace contains all the US, as the toys dataset is of US. The product category is all toys. Okay, the product parent, the title of that particular product, and the rating. And what else we have? The text, the review of that particular product, and the date on which it was, the day the review was posted. Okay. So now let's see. I did this operation because I think I was getting an object. So I'm just checking if the total votes is not 0. So just put that value after converting it into a numpy. And if it is 0, just put that directly into that column. So this is my data set, as you can see. Okay. So now once we have our data ready, what I thought of doing is, why not try to find some insights from that data? Can we get some useful information out of it? So the first thing that came to my mind, like, can we see, okay, so what are like the maximum data is of which kind of product? So I'm getting those products. Okay. So I'm doing is what? I'm just, doing the value counts in product title, and I'm just checking the 10 items out of it. So these are those 10 values, and we plotted into our simple bar plot. So this is our data. Okay. Okay, so now I know about that. So our next goal was to see, okay, why not also see the top 10 products, like the number of products which we have, the top 10 out of those, and let's see also the rating of that product, like what kind of rating has been given to that product. So how we can do that? That's pretty easy, guys. Same, I'm doing the product title column I'm using, and I'm checking the value of that each particular product, and I'm getting out of all those the 10 largest, which has the largest values, and I'm storing that into the name counts. And to filter that data, I am again checking is the product title which is in this index, give me that data. So that is my filtered data. Okay, so once I have all that, I can just group that by my product title, star rating, and then value counts. And I'm using unstack as I want to plot a bar plot, which is like a stacked plot. Okay, so this is what you will get, guys. So as you can see, we have this product that is Cards Agent Humanity. In this, the majority of the rating is a 5-star rating. And in the second place, we have a 4-star rating products. So this is a good way of visualizing. You can see, okay, in my data, the majority of the products which are like out of the top 10 titles which we have in my data, out of this, one of the product has maximum of 5-star. Almost all have maximum 5-star rating. You can see like that. Okay, so now let's see what all we can find information about. As you know, we have two more columns, that is the total votes and the verified purchase. So I also wanted to see for those 10 products, the top 10 and largest products, what's the ratio, guys? So what's the ratio of total votes and the verified purchase? So for that also, we plotted a subplots, like creating two plots like this. What we use is a subplot, and we define the figure size, and in axis 0 we are doing the voting count, and in the second axis we are using a verified count. So this is that. The maximum voting count is for the Cards Against Humanity, and the verified purchase count also. Okay, so we have, we got our data, we did some visualizations, and we have somewhat idea of the data. So now our next goal is to check whether we have any null values in the data. Because as you guys know that if we have null values in the data, we have to do some pre-processing, guys, as we cannot pass that values directly to our model, right? It will give error to us. So if we had null values, what we have to do? We have to do imputation, or we have to drop those rows or columns, or we might have to do one hot encoding. It depends on the situation, guys. Okay, so we are lucky in that scenario as we do not have any kind of null value, so that's a good thing for us. So now let's see. We also see, okay, we use the describe method to find out the various statistics or the stat values, like such as standard deviation, the minimum value, the maximum value, the 25% IQR, 50%, 75%, and so on. Okay, so what we can check in this, okay, this we can see, okay, the standard deviation value in helpful votes and the verified, yeah, in the total votes is around 8 and 9%. Okay, so that is something we can see. This is the maximum amount of these. Okay, and we can also see the data types. It's very important, guys. We check the data types because if we cannot also pass direct object values to our machine learning model, it should be an integer or a float value. So we can see, okay, all these values are object values, so we have to take that into consideration as well. Okay, so let's see what we can do then. Before doing any kind of operation, dropping any rows, columns, I just wanted to see any kind, if we can find any kind of relationship between different columns. So how we can do that? We can do that using a correlation plot. Okay, so what we can do is, and using correlation plot, we use an heat map, so it actually helps us in visualizing that in a very beautiful way. So what it will do is it will give us something like that, and we can see, okay, for star rating and helpful votes there is a correlation of negative 0.066. So what does this negative signify? Negative is like the negative inverse correlation, means if a particular value is increasing, the other value will be decreasing. That means if star rating value is increasing, the helpful votes value will be decreasing. Okay, it's inversely proportional, guys. So we can check the relationships among different columns this way. Okay, so once we have that, we also plotted this pair plot. Okay, so this is like kernel distribution estimation. I'm not sure about that, but I think this is what it is, and this is the regression. So what it does is in the diagonal, it plots we can check the distribution in the diagonal, and for the rest of that it plots a scatter plot, and it tries to fit the best line out of it. Okay, so we can see, okay, for this particular thing, yeah, it is somewhat like linear regression model can be made, as majority of the lines are passing through that straight line. Okay, now let's go below. So what else we can do? We can check the outliers as well. Okay, so for that we have selected total votes column, and we plotted the box plot. As you know, the box plot is like the best way to check an outlier. So, and we can see, like, we can find lots of values, like made according to the box plot we have many values as an outlier. But as you guys already know, right, we cannot take that as directly as, okay, if a box plot is showing us so many values, it's definitely an out. It cannot be that case. We have to think logically as well. As you can see, like, this is a total votes value, right? So there might be particular products in the votes value are really high, like that's a very popular product. Okay, like a Sony, you can say a Sony PlayStation, that's a popular product. And there is some local product, local gaming console, for that there are not that many votes. Okay, so we cannot say like all of them are outlier. They might be representing some good value to us, so we are not dropping anything for that. And out of these two, we are predicting star rating. Okay, so we thought these columns such as wine, product category, marketplace, they should not be of any importance to us. Okay, so that's why we are dropping all that columns from our data frame. So okay, before proceeding further, we also wanted to do one more visualization. And that visualization was, out of in my data set, I wanted to see the percentage of rating, like how many 5-star rating products are there, 4-star rating products are there, and so on. And we used the bar plot, pie plot, and we've also plotted the distribution. So as you can see, the majority of the data, like 33.33% data, is a 5-star rated product. And on the second number, we have a 4-star rated product. So how we did that? What we did is we grouped by the rating and the verified purchase, and we checked the count. And we plotted the his plot, and for the pie we use this, and for the dis plot we use this. Yeah, so we pass x as the star rating, we defined our bins as 5, so that's how you can get that information. And we also wanted to see the top 5, the rating, right? We also wanted to see how many of that is a verified purchase and how many is that a non-verified purchase. Okay, so how we can do that? We also did by group which we created, we unstacked that information and we plotted that information. So now it's time to see, do the feature engineering. Okay, then I thought, like, is it possible to extract more information from that date column, that review date column that we have? Okay, but that is, we have to remember, guys, that is in what data type? That is an object data type, and we have to convert it into date time so that we can make use out of it. So what we did is we used the date time to date time function of pandas to convert that into year, month, and day, and we stored that into the separate columns. Okay, and what information you guys think can we extract from that now? Can you guys think of something? Actually, what we can do is we can see the trend, guys. Something like this. The rating trend, like in what year the rating was maximum, in which year the rating was minimum. Similarly for the months and similarly for the day. Okay. Whenever guys you have a column, I would say like you can do something like this. You can convert that into a date time and you can actually visualize the trend. It actually gives very good insights about the data. So this is what we can do about it. Okay, so once we are done with that, we drop the review date column as you already extracted all the information from that. So now it's time to work on the review text, the comment section or the reviews which the customers have given to us. Because if we guys think logically, right, that column might be of high significance for us if we compare that to a rating. If a customer has given a very good review about a particular product, then we have a very high chance that the product will have a very high rating. Okay, so but we cannot pass that whole text corpus directly to our machine learning model. We have to do some pre-processing regarding that. So for that, what we did is, first of all, we have to pre-process that text, and then we have to convert it into the numerical format. So how we can pre-process? We can pre-process using all the digits, the alphanumeric characters we can remove. We convert all the text into the lowercase. We remove the punctuation out of it. We tokenize it, means separate it into word by word, different words. That's what we call as a tokenization process. And once that is done, we perform the stemming process. There are mainly two steps, guys. One is stemming, one we have lemmatization. What stemming does, it stems that particular word into a base word, such as we have a word running. So when we stem that word, it's going to convert that to run. Similarly with working, we have working. When we stem that, the base word is work. So that's how it works. So what we do is, once we have done all that, we join that into a text. So we have that with us now. So now what we can do is we can split our data into the training and testing. Okay. And for testing, we have used the 0.2% data. Okay. So we have pre-processed our data, but still that is not in a numerical format. We have to somehow convert it into numerical format so that we can pass it to a machine learning model. So mainly we have two main techniques for that. We have bag of words, we have TF-IDF, and many advanced things are also like word embeddings and all. But first of all, we started with the base. We started with the bag of words. What bag of words does is it counts the number of the occurrence of each and every word. Like if the word hello is occurring 5 times, rather than writing that, we are going to write 5. Okay, we are converting that into a numerical value. So we are using the count vectorizer, and we are performing that operation into the review text of my training data. Okay, once that is done, I'm converting that into the data frame, because it's going to give me, and we're converting that to an array, then converting into a data frame and storing into the separate data frame we are storing it. And think like this, guys. So it might be possible that we have lots of columns after doing this. Okay, so as my PC was not is not able to process was not able to process that many columns. So what I thought of doing is, for now, I just thought of doing a dimensionality reduction technique I used, such as principal component analysis. So what it does is, if I have lots of features or lots of columns in my data, so it reduces that, or it projects that into a lower dimension. So I used a hard value such as 20. You can try with other values as well. So I converted all that into my 20 features value. Okay, and I again check the shape. Okay, so the shape is now 20, and my training data has 16,000. So my testing data will have around 4,000. So that is done to us. That is good. Okay, so now let's move forward. Okay, so we just concatenated the train by train. Okay, that makes sense. And the next thing is creating a machine learning model. So for that, we used 3 machine learning models. That is a decision tree classifier, random forest classifier, and the logistic regression, as it is a multi-class classification problem. And for that, after that, we are going to check the classification report and the confusion matrix of all these models. So once we run our model through all these, we can see, okay, my decision tree is not performing that well, as it is giving me only 38% kind of accuracy score. Okay, so when I do that for all, I can see this is the confusion matrix, and the best model is somewhat logistic regression with about 62% accuracy. So once we have our baseline model ready, so what's the next step? The next step is to improve that particular model. Okay, so how we can improve? So there can be many ways, guys. First way is to use more data. Second is to select good features, and the third is to somehow do hyperparameter tuning and improve the model. So we went with the third step, and we tried doing hyperparameter tuning. So what is hyperparameter tuning? Hyperparameter is like different models have different values which we can tweak to actually improve our model. Such as for random forest, we can select the number of forest we can get out of it. Okay, so those are some of the values which you can change. Like we use the n estimators and maximum depth, and we selected, okay, these are the 3 values. Now give me the result for all these. So after doing that, also the accuracy which I am getting it around 61%. So I thought, why not, rather than doing the bag of words which we did earlier, why not try with TF-IDF also? Okay, so we did TF-IDF after that, and once we did that also, our model was not performing up to our standards, guys. It was still giving us somewhat similar accuracy, because we did everything again, and it was still giving us around 62%, which is like not that good. Okay, so it might be that our data, we might need to increase more data. We might need to get more data to improve our model. So once that is all done, we also thought, why not, check whether a review is positive or negative. How we can use that? We can actually use the wordnet library for that. Okay, so once we did that, we got the list of the positive and the negative words using that, and we loop through each and every word, and if we are just seeing if that particular word is in positive words, we are assigning it a value 1. So we have counts of all the positive and the negative words in that. Okay, and we can subtract that to get actually sentiment score of that particular comment. Like we can see, like for this we have a comment of 71 in positive. Okay, so that might be a positive comment. So yeah, this is how, this is like an overview of how we can work end to end, from data visualization, feature engineering, checking null values, outliers, machine learning models, optimizing that model. You can do all these operations, guys. So I'll be providing the link for this down in the description. And if you guys have any queries, just post it down in the comments. And if you want me to make a video on a particular topic, I will do that as well. So see you in the next video, guys. Take care. Bye bye.